In this video, we'll talk a little bit more about what's in a mole. In the last video, we defined a mole as the number of atoms in exactly 12 grams of carbon-12. Since one carbon-12 atom has a mass of 1.9926 times 10 to the negative 23rd grams, the number of atoms in 1 mole of carbon is 6.022 times 10 to the 23rd. So this is a useful definition for us. We can use it in lots of ways. For example, 1 mole of carbon-12 has 6.022 times 10 to the 23rd atoms. So it gives us a way to count. Counting in chemistry is all about moles. We can also think about, what if we had 1 mole of carbon dioxide? Well, that's a molecule, so we would have 6.022 times 10 to the 23rd CO2 molecules. And since each of those molecules contains 1 carbon, it would have 6.022 times 10 to the 23rd carbon atoms in those molecules, and 2 times 6.022 times 10 to the 23rd oxygen atoms in that 1 mole of carbon dioxide. We can use this also for formula units, like a mole of sodium chloride or table salt would contain 6.022 times 10 to the 23rd sodium chloride formula units. Sodium chloride is not a molecule, but rather a three-dimensional array of ions. So this gives us an idea how we can use the definition of a mole to answer questions about how many atoms, how many molecules, how many formula units, how many people, how many P's. We could count anything we wanted using the mole. So let's look at a few more examples. For example, how many hydrogen atoms are in 10 grams of water? So we need to connect grams of water to moles of water. What connects grams to moles? Molar mass. So we need to find the molar mass of water, H2O. To find the molar mass of water, we need a periodic table, which we'll use often. To find that molar mass of water, we say that there are 2 hydrogen atoms times its molar mass, 1.00794 grams per mole, plus 1 oxygen, which is 15.9994 grams per mole. So the molar mass of water, when we add this up, is 18.0153 grams per mole. So now we know how many grams are in 1 mole of water. That's what the molar mass tells us, the number of grams compared to the number of moles. Now we can use that as a conversion to go from 10 grams of water into how many moles of water. So we know that there's 18.0153 grams in 1 mole of water. So this tells us we have 0.5551 moles, a little less than half a mole of water in 10 grams. But we still haven't answered the question. The question is, how many hydrogen atoms are present in 10 grams of water? So now we need to do another step. So 0.5551 moles of H2O. For every 1 mole of H2O, there are 2 moles of H. So that means we actually have in that 10 grams of water 1.110 moles of hydrogen. 1.110 moles of hydrogen As we saw in the previous slide, we can connect for every 1 mole of hydrogen, just hydrogen, there is 6.022 times 10 to the 23rd hydrogen atoms. So in that 10 grams of water, we have 6.685 times 10 to the 23rd hydrogen atoms. So we can now use our ideas for molar mass and the idea of the mole defining how much and how many. Let's do another quick question. How many moles of hydrogen are in 10 grams of methanol, CH3OH? All right, so we also need to look at the periodic table and find the molar mass of methanol. In this case, that molar mass is going to be 32.042 grams per mole. So we're adding up 12 grams for the 1 carbon, 4 times 1.00794 grams per mole for the hydrogen, and 15.994 grams per mole for the oxygen to get that molar mass of methanol. Then we can use that to convert our 10.00 grams of methanol into moles of methanol. And we find that we get 0.3121 moles of methanol. And then we can go one more step, 0.3121 moles methanol, and convert from every 1 mole of methanol, there are 4 moles of hydrogen. So we have 1.248 moles of hydrogen in 10 grams of methanol. So a lot of this requires using the periodic table. So far we've talked only about finding the molar mass of each element on the periodic table. So I want to talk a little bit more about the structure of the periodic table and how it's arranged and why it's arranged the way that it is. So first of all, we see that it's not arranged alphabetically. It's arranged in order of atomic number. And that's because the structure of the atoms connect with the number of protons, neutrons, and electrons in those atoms. So some main things, we have periods which go across and groups which go down. So periods are labeled 1, 2, 3, 4, 5, 6, 7, and groups are numbered across the top. The groups also have names. The first are the alkali metals. The alkali earth metals are the second. These are called the halogens, and these are called the noble gases. And there I have a fancy picture of that, labeling each of those on our periodic table. And let's go back. We can also think about what are called the main group elements. So the taller ones on this side and this side are called the main group, or the representative elements. And everything in the middle is the transition metals, because we're transitioning from one kind of main group element to another. The final thing I want to point out is this line that differentiates between metals on this side and non-metals on this corner. So we have things along that line like silicon, germanium, and arsenic, antimony, tellurium that are kind of like metals and kind of like non-metals. We sometimes call those metalloids or transitions.